Maybe it is better. Oh, yeah, I hear myself now. Okay, thank you. That was my question. Now you hear all the noisy. Okay, so IPv2 can do it. As I said, can provide you fake information. Another way of doing it is the draft of the IETF to provide the PVD, so the provisioning domain, all this information through the HTTP, plus a signature, an RSA signature on it. There's another way of doing it. We love route advertisement, right? So we can send as well PVD there through route advertisement, also with a signature. And we can even use, in this case, send, secure neighbor discovery. But we all know that nobody is using send, right? So it cannot really be secure. And you will see it's not enough. Quite often at the IETF, specifically if you do it working groups which are not focused in security, they think, oh, I apply some crypto salt on my recipe, then the end result is secure. But we all know that it's not because you do crypto that the result is secure. And we'll see this. More information if you want. There is also something called source and destination routing. Remember the thing where I was saying, how can I exit if I have multiple layers of routers and I want to go to the internet by using the blue prefix, and I was exiting by the red prefix and being blocked? I can fix it if all my routers are routing not only on destination like they do right now, but they do routing based on destination and source. Now your routing table are basically for source prefix and destination prefix. And then of course, you were using the blue prefix, then you are following this path and you exit through the blue router. We can approximate this source routing by using policy-based routing, if people know about the Cisco language and CLI, or by using multiple VRFs. And you have one VRF, one VLAN, right, basically, per source address or source prefix. But it's ugly, right? That's not scale, because you need to configure this on each and every router. While there are new protocols that are discussed in the routing working group and the OSPF working group that basically can extend OSPF to get routing tables without any configuration using the source and the destination. Okay, so that's a bit scalable there. It's still draft, so no implementation. OK. This was for the introduction to multiple interface and multiple prefixes. And it's basically, by the way, leveraging new features of IPv6. We are now in 2015-16 at the verge of seeing new innovation thanks to IPv6, thanks to multiple addresses and thanks to extension headers and so on. So using arrays to provision PVDs. Remember, I think it was Mark Hersey that found it a couple of years ago, if you are flooding a Windows machine with arrays containing multiple prefixes and always changing prefixes, after I think it was 16 packets or so, blue screen. Okay? Hopefully it has been fixed. I have no clue, to be honest. But what if now the bad guy, look about the head, it's black, so it's a black head, right? Is sending one route advertisement with one PVD, then another route advertisement with another PVD, and something, until if there is a bug, it smokes. The issue here is that you are pushed. You receive PVD information even if you don't like it, even if you don't ask for it. That's a push model. DHCP is a bit more complex to do on this attack. Now, what if another reflection attack? I mean, this is pretty well-known attacks. Again, those people working into the PVD and the MIF group are not security people. So they were assuming, oh, I'm doing a security signature, a digital signature, I'm fine. So now, you have the handset with a 4G and you are roaming, so very, very expensive. And you have the free Wi-Fi at the hotspot, which is completely unprotected. Okay? Everyone can send packets to everyone. Now, what if the bad guy knows that you are connected to your ISP, and of course then he knows the address you got and the prefix, so he's sending to you ping, he's doing a spoofed address from an address which is routed over the 3G. Oh, I'm receiving a CMP echo request. I reply to address A, and I'm routed over the 3G. It cost me money. Okay? Again, nothing dramatic, really, except for money. And then in this case, we've seen people asking to the provider, hey, I did not send this data. Okay? Something is wrong. I don't pay my bill. You were doing this.
The question is more, is that sort of a reflection attack like the amplification we have with UDP?
Yeah, that's a just reflection. It could be even maybe if you find one packet and then you do amplification, could be there. But on the handset, amplification, I don't know, you could.
LTE, 21 megabits, and a handful of handsets, and.
Oh, yeah, okay. Okay, on this one, yeah.
Maybe move into 5G, and we've got.
I was thinking about, yeah, okay. I was more thinking about the one packet means multiple packets, but you can get multiple handsets.
And the strong Wi-Fi sending small ping requests for large response, stuff like that?
Yeah, but usually get, anyway, you get the point, right? So that's something that can be really, really annoying. And the other one now, you are connected over the VPN, and you know a lot of VPN has got a no split tunneling policy, but for good reason. I use VPN here, but could be maybe the Wi-Fi or something different. Or you are connected over the wide to your corporate network, and you forget to disconnect your Wi-Fi, and somebody is connecting to you over the Wi-Fi, and there is no split tunneling there. And even if it's there, and it's something that really annoys me, I'm running Outlook on my Mac. Obviously, when I'm disconnecting from my VPN, my Outlook will still request to the DNS server the IP address of my inside. I mean, the secret is not big, right? It's mail.cisco.com. So you can guess it anyway. But I'm guessing, hey, what is mail.cisco.com? Is asking this, the question, to somebody outside. Then somebody outside can know what kind of machine I want to connect to. Okay? As well for some other web servers and something like that, because they keep refreshing. It fails, they ask, go back to the DNS and ask, what is the IP address of this? So the bad guy will learn about this. And now if the bad guy is really bad, and if I'm really, really stupid, it will reply with an IP address to run a man-in-the-middle attack. Okay, or fake a server, present wrong information. That's basically, I can intercept myself, I can insert the attacker between the good and the bad, man in the middle. And everything there is mostly because PVDs are pushed and not pulled. The authentication is just a signature, but they put no anti-replay, so you can replay with all addresses, with all PVDs. So it's really, really kind of bad. So together with two other guys from Cisco, and one guy was looking at OpenWRT, we can do something very nice with V6. IPv6 addresses are unique globally, right? So if you go on this draft, what if I am doing a reverse DNS on my V6 address and not looking to a PTR records to get my name, but looking to a TXT records that I can identify as a PVD. And these TXT records, I will get all the information. The prefix, already got it, for which I should use which next op, or to which services should I use this source address, what are the DNS server, which is for which zone. So for instance, I could say, hey, use this Cisco address only to reach Cisco internal host, only using this prefix, and use this DNS server only to resolve something ending up by .cisco.com. All the rest, you use your ISP. to get the best of the both worlds. Okay?
One question.
Sure.
Who uses this information? Applications only, or is it also used at the IP stack level?
Okay. Part of it is used for selecting the next stop at the kernel, right? That's one thing. But of course, the application need as well, in some case, select the address.
Okay, so this would solve the long-standing question of how does an application know which prefix or which address to use? The colored prefixes and all this kind of
Exactly. That's, it was called colored prefix as well. It's exactly the same point. Now, the application needs to be trained to do this, because in some cases it's clear. It's basically based on the name, on this frequently qualified domain name, but could as well be different. For instance, if you have something which is cheap but slow for connectivity, one thing which is expensive but fast, the application cannot always select. It's up to you to select. So we start to see pretty much like you can download your application on iOS or Android. You specify over Wi-Fi only, not over cellular, or not over cellular when roaming. You will mostly get those kind of tuning based on PVD names. Because something which is really annoying for me, I'm using, for instance, a 3G router. And when I was in the ICE train coming here, and I pay because I was roaming in Germany, my bloody Mac, oh, you have a Wi-Fi. Oh, my bloody iPad, oh, you have a Wi-Fi. Download stuff. And I get wondered with Mac, so I pay something like 10 euros, right? I didn't die, obviously. But simply because it was telling running, oh, it's for Wi-Fi, it's free. Why should they said on this PVD, it's Wi-Fi, but it's expensive? You see, that's not applied to security, but simply on operation. Yeah, so most of it in the kernel, part of it into the application. So the beauty as well of this draft is that it's simple DNS request, so no need to change into the CPE or into the for your ISP. It's completely transparent. Also, it's a pool model. It's only when you want to get this information that you fetch it by DNS. So nobody can flood you with multiple PVDs. So it's a bit more stable. And of course, DNSSEC is your friend in this case. And there is anti-replay because of the TTL. So a lot of goods. And to be honest, since we proposed this draft, when was it, in October or November in Japan, things are moving forward again because it was blocked before. So again, it's not about something which is shipping right now, but expect something around this in 1 year or 2 years. Now, the thing is that I said IPv6 addresses are globally unique, but you know about network prefix translation and PTV6, then your address is no more unique. And there is, basically, it's no meaning. You cannot use the trick. So the source routing is basically it, right? So now I was using source routing from the source A, basically to follow the dotted line because it's cheaper, it's faster, whatever, right? You don't really care. So each and every hop are using not the shortest path to the exit, but using a really well-defined by source destination routing. Now, the router there on the top, this one, is also a default route to A. It's using himself the shortest path this way. So you know what? Strict unicast RPF checked. We'll say, hey, I'm receiving packet source A, but it's not coming from this interface. Drop it. So that's really where we are finding those kind of problems right now. In this case, it's very easy. If this one is also source destination routing aware, is doing unicast RPF check by using not only based on the source, but also the source and destination. And remember, we flip the source and the destination in this case, and we look where this packet should be coming from. Okay, and then it works. The only thing we are really is still brand new, so we may find another issue related to this routing, which is not the optimum routing, at least in the cost way. We have heard about changing topic now, extension headers. good, bad, and something like that. But don't forget, extension headers are the way to extend IPv6, and we will be stuck with IPv6 for all our life. So we need to keep them. And if we do some kind of specific traffic engineering, we can extend traffic engineering, so specific paths, to do what we call service chaining. So you need first, for instance, to go through a firewall, then through an IPS, and then, let's say, to a crypto device. And you need to be sure that all of the data, for compliance reasons, for instance, in data center, are going through all those services. That's your policy, and you need to comply to. Okay? Specifically valid into an NFV environment. If you're using physical box, you can still follow the cable. Right? It's going from this firewall to the switch on this port, and from this port to the, let's say, the IPS. Easy. Now, if everything is running over VM, you don't see the cable anymore. So it's a little bit more complex with the compliance. So for instance, this packet is only bypassing the firewall and the IPS and only doing to the crypto. It's out of policy. So how can we detect this? One way is to get some controller, as you know, whatever, it's not really important here, that will add some metadata to all packets as they're going through the chain. So we insert a header between the V6 and the TCP, let's say, or the UDP. And this header, every service in the chain will add its own data. So at the exit point, what you call the verifier, we can have a look inside and see, oh, you have been through this place, and this place. That's fine. Okay. Obviously, it's not simple to say, to flip a bit on each and every services. It would be too easy to cheat with. So we need to find a way to make it secure. And what we will do, we will be using Shamir secret sharing, SSS. And basically, how it will go, high-level pitch. We will take a secret, remember, like the white light. We will split the white light in all the colors. So we split the secret in multiple pieces of secret. And each and every device will add the red, the yellow, the orange, the yellow, the green, and the blue. And the verifier, it needs to add again all of those colors to find back the white. Of course, again, it's not this high-level view. Basically, we get a secret only known at the entry point and the exit point, the verifier. We split this secret in all the services. Each service has its own colors. And at the end, we put all of this together, and we check whether it's good or not. OK. How do we do it now? But how many of you knows about this secret sharing from Shamir? Nobody? You know? OK. I mean, I was unaware of it, to be honest, about 9 months ago. It's based on the fact, how many points do you need to define a line, a straight line? 2. How many points do you need to define a parabol? 3. 3, sorry. Yeah. OK? And so on and so on. So if you have a cubic function, like this one, x cubed plus blah, blah, you need 4. So basically, you always need 1 point more than the order of the polynomial. OK? So if you have a polynomial of the degree k, you need k plus 1 points. Right? A line is a polynomial of degree 1, a plus bx. You need 2 points, and you define the line. So now, the Shamir secret sharing is basically based on this. You have a secret, and the secret is actually the number here, the 10. And you random 3x plus 3 x cubed, for instance, is square. OK? Simple polynomial. Now, on this parabol, which is here, you take 3 points. 1, 2, and 3. So x equal 1, x equal 2, x equals 3. And you compute the result of this, and you get 16, 28, 46. So you have 3 points on this line. All of those 3 elements have got only 1 point. If they put their shared knowledge together, they got back the 3 points on the curve, and they can find back the equation, the polynomials. And in this case, the secret is number 10. Easy, right? And we know there are ways called Lagrange polynomials that we can take multiple points, 2, 3, 4, 5, 6, whatever, and compute back the coefficients, so the 10, the 3, and the 3, in a kind of efficient manner. Okay? We have done this when we were at the school. 3 points for parabol, get back the parameter of the parabol. Easy. Computers can do it. Based on this, that's basically what I'm explaining. We will mark all packets to be very optimum with 2 polynomials. One, polynomial 1, and we gave only known by the people injecting the first header and the one collecting the header at the end on the service chain, with all the parameters, right? So the coefficient A1, B1, C1. It's known only by the verifier. Nobody else knows about it. But then the verifiers put with x equal 1, compute the result, and give this shared secret to the service 1. You replace x by 2 and get this point, 2 plus the point, to the service 2. And you guess for the service 3 and service 4 and something like that. Okay? He only knows it. Now, we got another polynomial with coefficient of B2, C2, and something, and we give those B2 and C2 to all people in the service chain. So it's a kind of public. Okay? And for each and every packet, so this one will stay forever. For each and every packet, we insert a random number in the packet itself. So it allows every node on the path to recompute this. So I am service 2. I can, with this random that I'm getting from the packet, compute this. And I got another point into another curve. Now, I am taking my number that I receive here, which is secret, plus the numbers that I have computed here. I got 1 plus 1, making another number. And this is this number that I am sending in the packet. The verifier now, he knows this number, he knows the curve, so he can reconstruct it. And based on this and this knowledge, he can as well reconstruct the other polynomial. And he verifies simply by making a difference whether what is computed because he knows the curve plus the computing is just done for this one equal the number he's receiving in the packet. Okay? Now, we need this one, which is constant, because not a single node in the service chain knows about it. Even if they all team together, they won't be able to reconstruct the polynomial. So it stays always constant. And this one, even if people, the service chain people, can reconstruct it, because they all share the secret, so all the services can do it, it's not enough for them to be aggressive. The point is that we should not allow a service to pretend that the packets went through all the services. Because, for instance, if we assume a firewall which has been under attack, which is compromised, we should not allow the firewall to pretend that packet has also gone through the IPS and through the crypto. Okay? So basically, that's using very simple techniques. And I find it very easy somehow. Yeah.
We're only ensuring that the points have been passed, not the order.
That's correct. That's correct.
So adding a check for the order would be just another layer.
Yeah. Actually, the way we present this, we have this, which is very efficient, and the other one to ensure the order. The easiest way is that we have a secret per service, okay? And we put one number, and we encrypt with this, and then we need to decrypt. Now, the thing is that encryption and decryption is very tough. And it's the only way, I mean, we work on this with a couple of colleagues, and that's the only way we find to preserve the order.
But the order matters, because otherwise my state machine doesn't give me any info on what has happened.
Yeah. Now, it depends upon which kind of service chaining we are talking. For them, the order doesn't count. Now, the best way, if you really want to preserve the order, is not using a single service chain with 10 services, but using 10 small of 1, where the order is, of course, implicit somehow, and you verify at each point, which I understand is not optimum. But we were unable to find an algorithm which is efficient without crypto, and decrypt, and decrypt, and decrypt at the end. But I agree that for some services that's important. So really, when you get the slide, look at the explanation on the Shamir's sharing secret. It's a really nice algorithm. And the way we put it, it's simply on the extension headers. Now, whether you remember what I was explaining last year about segment routing, which is source routing, where you source packet to go this point, this point, this point, and this point, then you can use destination option to do it, or even using the segment routing header. Okay. Other point, talking about extension headers. Because Antonio talked about it, I'm pretty sure in every talk we talk about the extension headers, and we need to drop them, yes or no. And I think there are two different use cases, pretty much like Antonio has said. You as an enterprise as a destination or source of packets over the internet, or internet service providers being transit. If you receive packets, you should be really, really careful. Don't allow all extension headers, except if you're a university and even. Now, use a whitelist approach, because you know which kind of extension headers you should be receiving. And you should most probably allow fragments and use undetermined transport or whatever to be careful there. Now, it's well known that Google drops all fragments. So they find other ways, basically by playing trick with MSS, for instance, to drop fragments. Yeah, but you're not everyone can play this. For instance, routing at the type 2, which is used for mobile IPv6. So if you are using mobile IPv6, as far as I know, nobody's using it, but who knows, you need to allow them. But don't forget as well, IPsec are also extension headers, right? So you need to allow them, AH and ESP. And depending upon the way you enforce the rules, for instance, we were talking about, just to give you an example again, it was a bug somehow on the Cisco firewall, the ASA, a couple of years ago. So when we activate IPv6 there, it was checking only for known extension headers. Okay? So fragmentation, blah, 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 ESP, AH, then UDP and TCP. Boom. And a lot of people were using GRE tunnels over v6. Okay? Or they were using it in transparent mode, and then we were using EIGRP, the routing protocol, OSPF. There are also kind of layer 4 information. And you know, in the chain, you cannot differentiate between extension headers and transport protocol. So, OSPF. It's not fragment, it's not routing, it's not TCP, it's not UDP, I drop. So be cautious when you drop all the extension headers, right? A lot of things are numbers, but you never know. As I said, drop the first fragment without without the layer 4 in the header, so 7112, which is pretty good. And of course, drop the routing at the type 0. And regarding the hop by hop, there is a new trend now, discussion at the IETF with Fred Baker notably, that says, hey, if you receive a hop by hop header, don't look at it. Simply forward it. Again, over the internet. Now, if you enable something that requires hop by hop, like RSVP for traffic engineering, then you have no choice but to look at it. That's what you do in IPv4. Okay? So rather than ignoring or dropping, you may want to say, I ignore hop by hop only on interface where I do need services. And then you take the risk. That's a new trend. So now, if you're a service provider, as long as those extension headers are not attacking your infrastructure, like hop by hop, for instance, in some case, you should not drop them. You should do nothing about them, okay? In theory. But we see the theory is like, oh yeah, you can put containers and containers and containers on the board, and sometimes, boom, right? Too much is too much. So what is the situation? And there's been multiple, by Fernando, and I think Fernando is here, I see. So we can talk about it. Make multiple tests by sending over the internet to check really if extension headers are crossing the internet without being filtered or dropped. And the way he did it, he was using the Alexa top website, so it's a list of 1 million, the most popular website worldwide. And he was sending from a couple of vantage points or some source packets with varying extension headers. And he says, oh, in some case, the failure rate was 45%. So he was sending to 100 destination pings or whatever, I don't remember what he was sending, and he was receiving replies only for 55 of them. So 45 were dropped somewhere, which is not that good, right? Because it does not happen like this on IPv4. Another one, and another one, and another one, also with always using Alexa. Jelenkova from Google used the RIPE Atlas probes. So RIPE Atlas probes are small device that you can install in your home, and they are ready to make some measurements. So they do ping, trace route in the background, which is pretty. Oh, good.
For those who haven't raised their hands, think about getting one. It helps community and the understanding of V6 and V4 on the internet.
Yeah.
And it's free. You just approach right like they send you one.
And
I tried, but I applied for it. Okay.
but the thing is that they have too many probes in Europe. So they want to get 2 or 3 based on the location. But if you are a service provider or a user in Pacific Island or whatever, you will get one for free, for sure. But they got way too many. But it's really cool. And once you get it, you can also run your own test. So you can select the probes, let's say in Germany, 10 random, use this ping 6 to my destination, or use every day to my website, send me a ping, and send me the round trip time from 100 probes worldwide, and you do it once a day. That's really cool. And the last campaign on this draft was done last summer, again by Fernando. So when I look at this, I was not satisfied, because destination is the big websites, the Google and the Facebook. Does not represent end-to-end communication. It only represents client to server and web servers. Okay, so it's not enough for me. And it was not testing as well for routing header. And in Cisco, we were really interested in segment routing, which requires routing header type 4, or whatever number we will get. So we need to do something there. So our methodology, and I work with a student doing his thesis there from École Polytechnique de Paris in France. We still use the Alexa top 1 million, but the other source of addresses were simply taking the complete BGP routing table, so 22 prefixes or something like that, and sending packets to those addresses. Okay? And then we compare, we do trace route without extension headers, and we compare with trace route with extension headers. The way we managed to find for BGP, we were taking the prefix and simply adding colon, colon 1. Of course, big chance that there is nobody responding at this address. It could have been 10, random number, whatever. But most of the time, we will be receiving an ICMP message telling no such host, okay? Which is fine, because then if we know, if you look at the AS, autonomous system, of the destination address and the one sending us the ICMP, it simply means, yes, we reached the destination as the AS. It was enough for us, right? I don't need to check inside the AS That's their problem. As I said, if a destination AS drops extension headers, I'm fine. That's their right to do it, and they should do it, whitelist approach. But if there is somebody on the path which is dropping it, it's not their job. Right? They should not drop packets transiting over the internet. So that's basically what I'm explaining. There was a small caveat, is that there are ISPs, like DKIX, for instance. And for instance, the Google cache or a web property which is connected to DKIX, even if it's not managed by DKIX, got a DKIX address. So we need to know, for a lot of ISP, we need to understand that, oh, this IPv6 address is indeed one allocated to DKIX or AM6 or whatever, but it's actually going connected directly to Google, Facebook, or other. Okay, so there are databases for this, and we can do it. And for instance, what we go, for Alexa in this case, there's an option with 16 bytes, and we put some colors there, right? So everything which is green is OK. If it's either reach the destination, that's dark green, or drop by destination iris, again, I am the customer. I'm receiving packets with extension headers, like this option here. I don't like them, I drop. I'm fine. Again, whitelist approach for the end user is fine. And the red one, that's basically drop in transit. And you see a big difference whether you're at 16 bytes or the hop by hop, which is much, much bigger. But on this slide, you see the numbers for different kind. You can guess it, right? Decision option, hop by hop, atomic fragment, and source routing. Two different colors, and that's the drop rate. And we see, for instance, the larger the packet, 16, 128, 256, 512, high the drop. And honestly, I still do not have a clean and correct answer on this. My guess, but it's only a wild guess, is that a small decision option fits into the filter which is implemented in hardware in the line cards. So it can be parsed and say, OK, I have no ACL on decision option, go through it. Now, if I have only, let's say, 120 byte the looker at in hardware, and I'm receiving a packet whose extension header is 256, oh, I cannot do it in hardware. What can I do? They drop it, which could be understandable, right? If they want to inspect now, I still wonder why ISPs are inspecting extension headers, because they should not. Okay? Mostly they do it because they want to pass to filter on some TCP or UDP ports. Because to find the ports, you need to scan everything. But why would an ISP filter the transit traffic based on UDP and TCP ports? I have no clue. Yeah.
Have you tried aggregating that into a trace route and seeing if that's one large tier 1 carrier?
Yeah. So if you go there on this website, so btv6ving.org, you can select indeed for which, because we are running campaign every year, BGP Alexa 2015, 2016. Okay, you can select the test, and you say, click. Everything is more sensitive. So you click on something, you will see the AS dropping, and if you click on one AS, you will see all the dropping routers. And indeed, that's basically a few of them. That's NTT America. I don't know why, but there's a lot of destination behind it. Telesonaria. Now, the thing, as you say, can see here, it was about 10% drop. I think it was for fragmented packets. And now it's about 5%. In 1 year, it changed a lot because people have seen the numbers, have seen themselves into the blacklist. Say, should I really drop fragments as a transit provider? No, remove. So Telesonaria, for instance, has changed a lot.
Or maybe they just changed gear.
Or they changed gear. Yeah, I mean, they changed gear in the old sense, right? First gear to 2 gears, or one vendor to another vendor. I don't know. So the thing, we can do this for the big one, and we have tried. I mean, V6 up at the specific forums at the IETF, but it takes time. And you need to find the right person in the operator. But yes, that's a couple of clusters of big ones. Telecom Italia is another one, for instance. I found no German in there, so German is opening for everyone. Okay, and just a last request with a small wink for basically the three speakers of this morning. The three of us wrote together this MLD security for IPv6 draft. It's mainly Antonio, to be honest. We are lacking traction there. So if you can read it and review, and if you have never been in the IETF, you do not need to pay anything. You can review it, and there is a mailing list associated to it in the PIM, and you reply to it. So it will show that's interesting. It's about 5-6 pages, and it's pretty well written. Again, it's not me writing it. I mean, I put the structure. I did nearly nothing. It's Antonio and Neno did most of it. We need to protect MLD as well. It's in the PIM, obviously, working group, and they don't really care. For instance, something which is completely crazy for me, they are sending the MLD with up limit being 1. Okay? So meaning it can be routed to the internet to reach you. If you look about neighbor discovery protocol, like neighbor advertisement, neighbor solicitation, they are always sent with up limit being 255, and people receiving it check if it's not 255, I drop it. Could have been so easy to do it at MLD, right? So wait and see. So review it. It will be nice.